Okay, this is the last section of this unit, so this will be the last day that you have any kind of new material, and this isn't really new. It's pretty much identical to what we did yesterday, with one exception. Inequalities are handled exactly like regular equations, with, again, only one exception, and that is when you multiply or divide. Okay, it's only when you multiply or divide by a negative number the inequality sign gets reversed. Not addition or subtraction, multiply or divide, and by a negative number. That's when the inequality sign gets reversed. So let's start off with a fairly easy one. Say you have 4x plus 6 is greater than 54. Okay, you follow the same steps as with a regular equation. You've got 4x plus 6 is greater than 54. We want our variables on one side, numbers on the other. So let's subtract 6 from both sides, which will give you 4x is greater than 48 because these zero out. And then you want x by itself, so since we have 4 times x, you divide by 4 so that the 4's will cancel out, leaving you with x is greater than 12, which is your answer. Nice and easy, see? The inequality sign didn't change because we didn't divide or multiply by a negative number. Second example. Okay, and now it's getting a little bit harder. We've got negative 1/3 times the quantity, x plus 21, is less than 2. So you can, if you want, distribute that negative 1/3 over the x plus 21. However, on the other side is just a 2. Okay? So here's where I would multiply by the reciprocal. Now remember, the reciprocal, the sign stays the same. So we're going to multiply this whole thing by negative 3 over 1. Or if you want to just say negative 3, that's fine too, because it is the same thing. Okay, so we're going to basically make it this. Alright? So when we do that, these cancel out, leaving you with just x plus 21. And then 2 times negative 3 is negative 6. But look what we did. We multiplied by a negative, and we multiplied. So our sign switches to that. Okay? Now, we handle it just like we normally would. We subtract 21 from both sides, giving us x is greater than negative 27. Now, if I go back and plug this in, which you should, I know I didn't do it in the last one, but I'm assuming that you're doing this. But just for example, here's a good way to tell if you forgot to switch the signs. Okay, if you go back and plug this in, negative 1/3 times negative 27 plus 21, it's greater than 2. Okay, if I put the signs in right, this should be a true statement. Negative 27 plus 21 is negative 6. Negative 1/3 times negative 6, when you cancel stuff out, gives you a positive 2. Now, we said that x has to be greater than 27. So I'm just showing this as an example that if I used a number bigger than this number would be greater than 2. Okay? So if I use negative, because remember, big, when you're talking about a negative number, anything bigger than that should be true. So I could have used 0, and 0 would have given me a true statement. But if I had forgotten to switch the signs, it wouldn't have. Let's say if I had used 0 then, it would have said 0 is greater than 2, which is obviously not true. So the main thing I want you to get out of this is when you multiply by a negative number, this gets switched. Okay? Next example. Okay, we've got 8x plus 3 is greater than 2 times the quantity 4x plus 1. So get rid of the grouping symbols first. That means the parentheses. So we've got 8x plus 3. We're going to distribute. So we'll have 8x plus 2. Okay? So when we do that, we can get our variables on one side, numbers on the other. So let's start off with the variables. That cancels out, and actually that becomes 0 too. So that's going to leave us with 3 is greater than 2. Well, where'd our variable go? Okay. When this happens, this means that if it's true, all real numbers are the solution. Okay, if you're not sure what a real number is, come talk to me. All real numbers are the solution. So what that means is if I picked any number that's a real number, 1, -1, 5, 0.2, fraction, a decimal, a whole number. Any of those numbers, if I plug in for x, will give me a true statement, regardless of which one, because there's x on both sides. Okay? So if you do the math right, any real number will make that a true statement, meaning that all real numbers are the solution. Okay? Let's try another one. Again, get rid of the grouping symbols, so we have to distribute. Okay, when you distribute, keep in mind, this isn't 1, this is -1. So 3 times 8 is 24b. 3 times -1, -3. Yeah, this kind of looks familiar, huh? Let's see what happens this time, because I guarantee I'm not doing the exact same thing. Okay, again, let's cancel out, leaving you with just -3 is less than or equal to -4. Well, we know that -3 isn't equal to -4, and hopefully you know that -3 is actually greater than -4, and if it helps, make yourself a number line. Here's 0, here's -3, here's -4. Greater than goes this way. Okay? Less than goes to the left. Okay, since we're saying -4 is greater than, that would mean that here we are at -3. -4 should be this way, but it's not. So that's not a true statement. So again, this is another one of those where there's no solution. Okay? So, I cut it short. Just wanted to show you no solution, wanted to show you an all real numbers, and just wanted to give you an example of when you actually switch the inequality sign when you reverse it. So as long as you know that, the rest of this should be a piece of cake for you. But again, as always, if you have any questions, feel free to ask me in class, and make sure you're taking good notes.